Hello, my name is Caleb Dresser, and I'm an emergency physician and serve as co-chair of the Wadham Climate Change Special Interest Group. I'm going to be sharing a couple of thoughts over the next few minutes about how climate change is connected to disaster and emergency medicine, and we will explore some of these topics in future webinars as well. Let's get started. First of all, what is climate change, and how does this relate to human activity and the field of disaster and emergency medicine? Let's start with what we've been up to over the last few hundred years. We've been burning coal, oil, gas, and we've been changing use of the planetary surface, for example, reducing forest cover and increasing certain forms of agriculture. All of this has led to emissions of greenhouse gases. These are things like carbon dioxide and methane and other gases that act to trap heat around the Earth. This is a graph from a mountaintop in Hawaii over the past several decades showing the increasing levels of carbon dioxide in Earth's atmosphere. This is of concern because carbon dioxide, methane, and other greenhouse gases act to trap heat. They prevent infrared radiation from escaping into space. And so when you put more carbon dioxide, methane, and other greenhouse gases into the atmosphere, that essentially acts as a blanket around the planet that insulates the planet and leads to rising temperatures. We have already seen an increase of around 1.5 centigrade as of the time of this recording. The exact number depends a little bit on how you add up the math, but suffice to say, the planetary temperature is increasing and has already increased quite substantially over the past several decades. If we look ahead using computer models, what scientists are seeing is a very high probability of continued increases in global temperatures. How much that increase is, well, that depends on future and present day decisions about greenhouse gas emissions policy and ways to reduce greenhouse gas emissions globally. Where this starts to become really concerning from a health, disaster, and emergency standpoint is that planetary warming increases the risk of a wide variety of hazards occurring, increases the intensity of some hazards, and can create situations in which threats occur in new environments where they were not previously seen. Some of these include heat waves, which are becoming more frequent and intense across much of the planet, long-term changes in biomes, which can affect the distribution of a wide variety of both animals and plants and also pathogens, wildfires, long-term changes in sea level, which is rising globally, and a wide variety of other impacts. In terms of how we know this, there is a lengthy scientific record at this point to help us understand Earth's climate today in relation to Earth's climate for many, many years in the past. To share a couple of illustrative examples, these are graphs from the British Antarctic Survey, which has performed ice core drilling in Antarctica and been able to look back hundreds of thousands of years by analyzing the characteristics of gas bubbles trapped in the ice. And what they see here is that today's carbon dioxide levels are the highest that they have been in their entire time series, going back almost a million years. And today's methane levels are also the highest they have been in the past 800,000 years. This is concerning because when you look back at that same record, you see that there is a pretty clear correlation between higher levels of greenhouse gases in the atmosphere, as inferred from those little air bubbles in the ice cores, and higher temperatures, as inferred from analysis of other trapped gases in those same ice cores. This lines up with our understanding of the planetary system based on a wide variety of other science. And so at this point today, we are looking at a present day situation where we are well outside historical bounds and a future in which we can expect that we will remain outside those historical bounds and very likely will move further away from our historical experience over the last almost a million years. There are a wide variety of implications of climate change for health. Some of these are disaster related, some are not. This is a helpful image from the US CDC that was released a number of years ago, which explores some of the categories these fit into, ranging from disaster-related issues, for example, injuries and fatalities from severe weather, to very long-term changes in food security, perhaps resulting from changes in the viability of agriculture, resulting from changes in temperature and rainfall patterns in various parts of the world. So this is a large, complicated field. And when it comes to thinking about the disaster and emergency medicine aspects of this, there are a few different issues we need to be thinking about. I've situated these within the larger context of human activity leading to climate change. And if you look at what climate change is doing to hazards we are concerned about in disaster and emergency medicine, in many settings, it is increasing hazard frequency, exposure, and intensity. It's also leading in many settings to longer hazard seasons or even erratic timing of hazards that is different from historical patterns, as well as, in some cases, overlapping hazards. For example, tropical cyclones that occur and are immediately followed by a dangerous heat wave in the setting of large, widespread infrastructure damage and power outages. That one-two punch of overlapping hazards is also of great concern in our field. All of this adds up to increasing risk. And in a future webinar, we're going to look at how we think about risk in disaster and emergency medicine and how climate change can be relevant to our understanding and future assessment of risk in this field. For today, though, we're going to go through just a few of these hazards and connect some of the dots between our understanding of the impacts of climate change from a science standpoint, and then what this means for disasters and disaster and emergency medicine. Let's start with severe storms and flooding. At a very big picture scale, climate change means that more heat is trapped on the planet. That means more energy is available to power weather systems, and that can contribute to more intense and severe weather. In addition, warmer air is able to hold more moisture. So as a result, when hotter air takes up moisture over a lake or an ocean, it has more potential to create heavy rainfall. Together, this means that we are seeing more intense storms and more intense cloudburst events where large amounts of rain falls in a short period of time. This map on the right is from the United States, and this is based on historical rain gauge data. This is not a model. This is simply adding up historical weather data, showing a dramatic uptick throughout much of the country in the amount of very heavy precipitation that's occurring over time compared to, say, 40 or 50 years ago. When we look at hurricanes, we see something similar. Again, there's more energy available in the planetary system. Hurricanes, also called tropical cyclones or typhoons, feed off of the warm sea surfaces in the subtropics. And so more temperature, high temperature water, creates a situation in which there is more potential energy on which these storms can feed. That may be contributing to higher wind speeds and more risk of rapid intensification. This is also occurring in the context of warmer air, where these storms can thus dump larger amounts of rain in a short period of time, and also occurring in the context of sea level rise, which means that when storm surge occurs, it's happening on a higher baseline sea level, and thus there's increased risk of coastal flooding. There's also some science showing perhaps a reduction in the translocation speeds of some of these storms, i.e. the rate at which the whole storm system moves, creating a situation where a city that is exposed to one of these storms may experience impact for a longer duration. And there is some evidence in some ocean basins that the locus of maximum intensity, i.e., the point in the storm track where it is most severe, may be moving toward the poles, thus exposing areas that do not have as much historical experience with hurricanes. This is an evolving area of science, and there's a lot to read about here, and it's important to understand what is and is not known. The IPCC's most recent assessment report has a helpful summary of this literature and the level of confidence in some of these statements. When it comes to heat, the data is at this point quite clear and quite concerning. We are seeing increasing heat exposure. We are seeing more intense summertime heat waves. The heat wave season is also longer. Again, here is data from the United States. And again, this is not a model. This is simply adding up temperature records from weather stations over the past roughly 60 years. And what we see is more heat waves in most cities, and we see a longer season in which they can occur. This is concerning because heat is a potentially lethal hazard, and it becomes particularly dangerous when people are exposed to it and don't have a way to get out of it. For example, they're working outdoors or they perhaps live in a home where they don't have cooling. And so, this combination of higher temperatures for longer, as well as exposure of populations that are not necessarily used to dealing with heat and do not have cultural or social or architectural adaptations in place, is creating a lot of dangerous heat around the world. This, in turn, in settings where people have access to air conditioning, often leads to increased air conditioning use. And if the power grid is unable to sustain that increase in demand, can actually contribute to risk of power outages, which further increases the risk. There is a lot of work going on understanding the implications of heat in the context of climate change, as well as adaptation approaches to deal with this. When it comes to wildfire, we are also seeing increasing concerns around the world. This has been seen on most continents that have historical experience with wildfire. And there's a combination of factors here. Some of this is about hot, dry summertime conditions, the type of conditions that can support wildfire ignition and rapid spread. And so when you have hotter conditions and potentially increasingly erratic rainfall during summer months, that can create a tinderbox and high risk of fires occurring. On the background of this, it's also important to recognize that in some settings, the growth of fuel for fires during wintertime months, which are sometimes rainy, for example, in many chaparral areas, may mean that wintertime rainfall is actually contributing to the growth of fuels that increase risk of larger blazes in the summer or fall. So this is obviously concerning. In addition to the obvious dangers of the wildfires themselves, it's worth pointing out that simply trying to prevent them creates its own disaster and emergency management complexities. For example, decisions to turn off power grids to prevent sparks during very high-risk conditions may help prevent wildfires, but may also put individuals who depend on electricity for medical devices, refrigerating insulin, or other key medical activities, that may put them at risk. And so figuring out how to manage that risk and balance that is a very important question. Smoke is also a major concern. Smoke from these fires can travel long distances and affect the respiratory and cardiovascular health of people far distant from the wildfires themselves. And finally, after a fire has occurred, often landscapes have far less vegetation, far less in the way of plant root structures to hold soil in place. And so the risk of flooding and in some settings, landslides following wildfires actually goes up as well. And so we see this compounding and sequential escalation in disaster risk that we need to understand and be prepared to manage. Finally, drought is a longer term concern as well. Erratic rainfall and rising temperatures mean that there are many places around the world that are having difficulty with rain-fed agriculture or with availability of water in reservoirs. All of this can contribute to poor growing conditions, which has obvious implications for food security, particularly in settings where smallholder agriculture is very important to the economy, as well as for livelihoods. And there can also be feedback loops here where as you see less rainfall, there may be increased reliance on irrigation, which can contribute to soil salinity and long-term create further damage to cropping system yields. All of this, again, creates long-term risk that can contribute to food insecurity and even complex humanitarian emergencies. So in summary, we are in a situation where ongoing human activity, including burning fossil fuels and land use change, is leading to rising global temperatures. And these changes in Earth's climate are contributing to increasing disaster risk through, as we just discussed, a wide variety of mechanisms. How do we address this? Well, one approach is climate change mitigation, which means reducing greenhouse gas emissions and greenhouse gas levels in the atmosphere. That will help prevent the worst possible futures associated with climate change. But we also need climate change adaptation, which means taking steps to prepare for the impacts of climate change. So when they occur, when the heat wave occurs, when the tropical cyclone occurs, we are prepared, our institutions are prepared, and our societies are prepared for these impacts. Both of these at this point are necessary and are complementary together. At this point, we in disaster and emergency medicine are facing climate change. This is a reality we have to engage with, and it will have increasing relevance as its effects intensify. We'll explore some of those specific effects, some of those hazards, and some of the ways we can deal with them in future episodes.